Okay, so you just asked an excellent question, or you made an excellent observation that the mass number and the atomic number don't seem to have any units, which is a bit odd, isn't it? Every now and again, we do come across a quantity that doesn't have a unit, and there's always an explanation for it. And in this case, the atomic number. My understanding is that the atomic number doesn't have a unit because it's like saying atom number 2. So if you look on the periodic table and you go from left to right, and then you go back next row down, and you go left to right again. You got atom number 1, atom number 2, atom number 3, atom number 4. So atom number 1 we call hydrogen. Atom number 2 we call helium. And atom number 3 we call lithium. Don't want to keep going. I'm going to forget what they are. But so the atomic number just means which atom it is. Yes, you remember some of them. So that's why that one doesn't have a unit, because it's just saying which atom is it on the periodic table. So it's atom number 2. It also just so happens to also be the number of protons. I say just so happens. That's how we are defining which atom it is. It's by how many protons there are. So that's why that doesn't have a unit, though. What about the mass number? So the mass number actually does have a unit. We just don't often talk about it, and so when we say 4, we mean 4 atomic units. Okay, so or 4 AU. Okay, so now eventually in chemistry we'll touch upon a topic called moles. I'm just going to put here C moles, which is a topic, nothing to do with the creature moles, but think about the first 4 letters of the word molecule. So you can imagine it's got something to do with that. But we're not going to go into that right now. We're just going to see what is an atomic unit in terms of other units. Like how do we also measure mass? Because this is a mass number. Mass is also usually measured in kilograms. So let's find out how much is an atomic unit. So clearly we can see now that one atomic unit, a Dalton, which I didn't hear about before actually, but okay, so atomic unit is also called Dalton. We can look into that a little bit more detail in a moment, but we can say that an atomic unit is equal to 1.6 times 10 to the minus 27. So if you did a 0 point and then put 26 zeros after that decimal point, then you're going to that's going to be the mass of one atomic unit. So that's not quite right. 4 times 1 times 10. That's not right at all. Hang on a second. So, one alpha particle is 6.64 times 10 to the minus 27 kilograms. It's actually said if you did 0 point and then you put 26 zeros, and then you would put 664 kilograms. That's how tiny one helium nucleus is. So here's here's your task. Here's your little challenge. I want to know. How many helium nuclei are there in 1 kilo. Oh, in fact, we can ignore the electrons. Let's just to make it simple. How many helium atoms is in 1 kilogram of helium? Okay, that's your task. In fact, maybe I'll make it even harder. I'll give you 2 tasks. How many helium atoms, ignoring the electrons, how many helium atoms are in 1 kilogram of helium? And then how many water molecules are in 1 molecule of water? So without demonstrating the working out, it has this many helium, that should say helium atoms, which can be changed to 1.51 times 10 to the 26 helium atoms, and the water molecules is that many water molecules, or represented by 3.34 times 10 to the power of 25 water molecules. So see if you can work out that for yourselves. I'll stop that there.